It makes up 68% of the universe, but we can't see it. We know very little about it, but we feel its effects every day. It's all around us, but it's nowhere. It is invisible, dark, and mysterious. We are talking about dark energy, one of the most bizarre and least understood phenomena in the entire cosmos. Scientists believe that this mysterious force is accelerating the expansion of our universe. But what exactly is dark energy? How do we know it exists? And could NASA's new James Webb Space Telescope finally reveal its secrets? That's what we'll explore today. Do you need the big questions answered? Are you constantly curious? Then why not subscribe for more clips like this one and ring the bell for more thought-provoking content? When we look up at the night sky, we're seeing a universe full of stars and galaxies, planets and black holes, quasars and nebulae. But there's a lot more to the cosmos than meets the eye. In fact, scientists believe that the majority of the universe is made up of something we can't see, dark energy and dark matter. Dark energy is thought to make up 68% of the universe, while dark matter makes up a further 27%. That means that everything we can see, stars, galaxies, planets, black holes, nebulae, it all adds up to less than 5% of the universe. But how do we know that dark energy exists? Well, it is not exactly easy to detect an invisible substance that makes up nearly 70% of the universe. But scientists have managed to piece together some clues that suggest it's out there. One of the first pieces of evidence came in 1998 when two teams of astronomers were studying distant supernovae. Supernovae are incredibly bright explosions that occur at the end of a star's life. They're also incredibly useful as standard candles. By measuring how bright they appear from Earth, astronomers can work out how far away they are. This is because the brightness of a supernova is related to its luminosity. And if you know how bright it's shining, you can work out how far away it is. The two teams of astronomers were studying different supernovae and hoping to use them to measure the rate at which the universe was expanding. If the universe is expanding, then the light from distant supernovae will be stretched, shifting the light towards the red end of the spectrum. The farther a supernova is, the faster it appears to be moving away from us. And the faster it's moving away, the more redshifted the light will be. But both teams were surprised by their results. They had expected the rate of expansion to be slowing down, but instead it appeared to be speeding up. One team was led by Saul Perlmutter of the Lawrence Berkeley National Laboratory in California. The other was led by Adam Rees of Johns Hopkins University in Baltimore, Maryland. Both teams concluded that the only explanation for their results was that there must be some kind of repulsive force pushing the universe apart. This mysterious force became known as dark energy. To explain how dark energy works, physicists developed a model called the cosmological constant. The theory is that dark energy is a property of space itself. It's a kind of inherent energy density that's constant throughout the entire universe. As space expands, the amount of dark energy doesn't change, which means that it becomes less and less concentrated. As a result, the effect of dark energy becomes stronger and the expansion of the universe accelerates. Dark energy is also known as the cosmological constant, quintessence, or the fifth force, but no one knows exactly what it is. Some physicists think it's a fundamental property of space, while others think it's a field called the inflaton field, which supposedly played a role in the earliest moments of the universe. Others think it might be a sign that our understanding of gravity is incomplete. What we do know is that dark energy is everywhere. It's the same throughout the entire universe, and it's not affected by gravity. These properties make dark energy very hard to detect, but NASA believes its new telescope could be up to the task. On December 25, 2021, the James Webb Space Telescope launched from French Guiana on the South American continent. The goal of this $10 billion mission is to look back through time and detect the faint infrared light from the first galaxies that formed in the early universe. But along the way, it should shed some light on the mysterious phenomenon of dark energy. The James Webb is designed to detect changes in the color of light as it passes through space. This is because when light travels through a medium, its wavelength can be affected by the particles it interacts with. The amount of redshift or blueshift can tell astronomers a lot about the object they're looking at. For example, if the light from a galaxy is redshifted, it could mean that the galaxy is moving away from us. And the farther it's moving away, the faster it's receding. By measuring the rate of redshift, astronomers can work out how fast the universe is expanding. And that can help them learn more about dark energy. One of the main goals of the James Webb mission is to image supernovae in distant galaxies. By measuring the rate at which these supernovae are redshifted, astronomers will be able to work out how fast the universe is expanding. And that could give them clues about the nature of dark energy. In addition, the James Webb should be able to detect the polarization of light from supernovae. Polarization is a property of light waves that describes the orientation of the wave at a particular point in time. Light can be polarized in different ways, and each polarization state represents a different orientation of the wave. When light passes through a medium, the polarization state can be changed by the particles it interacts with. And this change in polarization can tell astronomers a lot about the properties of the medium. For example, if the light from a supernova is polarized in one direction, it could mean that there's a magnetic field present. Magnetic fields are created by moving charges, so the presence of a magnetic field would suggest that there are charged particles in the medium. Polarization studies could help astronomers better understand the nature of dark energy. One possibility is that dark energy is carried by a particle called the inflaton. If this is the case, then the light from supernovae should be polarized in a particular direction. By measuring the degree of polarization, astronomers could work out the mass of the inflaton particle. Another possibility is that dark energy is a quantum fluctuation of the vacuum. This is known as vacuum energy. If this is the case, then the light from supernovae should be unpolarized. The James Webb won't be the first telescope to look for these effects. Previous missions such as the Wilkinson Microwave Anisotropy Probe and the European Space Agency S-Planck satellite have set limits on the amount of polarization that can be present in the cosmic microwave background. However, the James Webb should be sensitive enough to detect any polarization signal from supernovae, even if it's very weak. If the James Webb does detect a polarization signal, it would be a major breakthrough in the study of dark energy. It would provide the first evidence that dark energy is carried by a particle. It would also tell us something about the properties of this particle. Of course, the James Webb won't be able to detect dark energy directly. All it will be able to do is look for signs of it. But this will still be a major achievement. As we know more about the properties of dark energy, it could lead to new insights into the nature of the universe. It could also revolutionize our understanding of gravity and help us develop new technologies. For now, we'll have to wait and see what the James Webb discovers. But one thing is for sure, the hunt for dark energy is just beginning. So what do you think? Is there anything we missed? Let us know in the comments. Thanks for watching, like, and comment your thoughts. Subscribe for more videos. Till then, bye.